if you want to scan the QR code, you can scan and join the present live. And group 3, 4, no 5, right? We still have 5. Okay. Okay, so let me continue. Today we will start chapter 1. Chapter 1 talking about basic simulation modeling. This is the outline. We will have a nature of a simulation first. As for the others, later we will reach them. So I go to the first one first. Simulation. I think you know simulation. Here I just want to emphasize we have the key term, simulation, a model of a set of problems or events. All right, so here we have the keyword. Actually, the keyword you can look up using your dictionary for sure. And let me try this for, okay, maybe the hyperlink here is something wrong, so later I will fix it. So this is the nature of a simulation. Of course, we need to run simulation. We will have a system. So this is a system you focus, all right? But for the system, you need to have the model. And then you run simulation based on the model. All right, so given a system, and you need to have the model. Then the model actually is an assumption, or maybe some way to form the assumption. And how to have the assumption? Mathematics or logic relationship. Based on this, and then you can have the model. If you have the model, then you can have the analytical solution, or maybe the solution via simulation. All right, so this is the nature of simulation. At least we need to have a system, and then you need to have the model. Well, so where we can have the simulation, the systems here, and I will try to emphasize communication networks, computer systems. All right, as for the others in the task, we mentioned inventory system. In fact, they can apply to all the possible areas here, but we emphasize communication networks, computer systems, and inventory systems. Well, if we have the simulation and you want to have the simulation, then we have the terms here, impediment. What that means? This one. Something that makes process or movement or achieving something difficult or impossible. So it's difficult. Well, so something here. make something different or difficult. And we have the simulation, then you need to have the model. And how about the large system or really large system? Then you have the complex model. So this is the first one. To have the complex model, it is not an easy task. If we have a large system, so that we have the complex model, then you need to have a large amount of computing or computer time. And final one, sometimes someone thinks you run simulation. Simulation is just an exercise. The thing is just an exercise. So you have the impediment. Actually, the real impediment are complex model and large amount of computing time. But finally, someone thinks it's just an exercise. Even you never mind that one if you want to use simulation, but it serves as one of the possible impediments. Well, so we pass on the system to have the model, and later we try to have some concept to have the simulation. So let us have the system models and simulation. Well, previously we emphasized the nature of simulation. We have a system. We need to have the model, and then we have a simulation. So we emphasize the next one, systems, models, and simulation. Well, system, here we have some further description. A system is a collection of some entities. For example, machines. I think it's easy. All right. Even you have the whole system, but sometimes you will focus on part of the system. And then that part of the system is the real system you focus. And right now, we focus on that system you are interested in. And for that system, we will define stats because you need to measure the performance. So you need to have the stat of the system. To have the system, normally we can have the discrete system or continuous system. And actually, you may have the mixture of both, discrete and continuous. But later we will have the discussion for the discrete event system first. All right. So if we have the system, and you may have a discrete or continuous, but later we will focus on this discrete event system. Well, discrete continuous, I think you can check the definition by checking countable or not. If we have a state countable, and then we will have a discrete discrete system, or otherwise you will have a continuous system. At this moment, maybe I just mentioned countable or not. You need to check that one so that you know discrete or continuous. If we have the concept of countable, and then we can define discrete system. If it's discrete system, then we have the countable number of variable, or otherwise uncountable stats, and then we will have the continuous system. Well, I mentioned this for your reference. If you want to check the definition of a discrete or continuous system, you can use the concept of countable. Well, up to now, I've mentioned a system. And for the system, actually, we will have possibly we will have the model. Well, first of all, if you don't want to have the model, you just want to have the actual system, you can run, or maybe you can do the experiment, and then you can have the result through the experiment. But otherwise, for the experiment, we have the model, right? We have the model, and once we have the model, please say that we have the mathematical approach. And mathematical approach, actually, we can have the analytical solution, or we have a simulation. So previously, we have the two branches. Even for the two branches simulation, we still need to have some mathematical relationship. If you don't want to follow mathematical model, then we have the physical model. As for physical model, in fact, we have the others, but we stop here. And likewise, we stop here. We just emphasize if we have a simulation or analytical solution, we will rely on a model, a mathematical model, and finally, we will have the analytical solution or simulation to have the solution. Well, that's it. This is a way to study a system if we want to measure the performance for the system you focus. Well, for the system, we know we can have a discrete or continuous, right? And in fact, we can have a static or dynamic. Static system or dynamic system. If the state, it won't change as time goes, then it's a static system. Otherwise, we have a dynamic system. And for this one, about some event, you can find it for sure, or we have uncertainty. If we can find it for sure, and then it is the deterministic. And if we have some uncertainty, then we have the stochastic system. Well, actually, we can have static or dynamic, deterministic or stochastic, continuous or discrete. And finally, we want to have a subsystem, this one, discrete. All right, so discrete, not static, actually is dynamic. Discrete, and then events actually we will have a stochastic simulation. So we choose discrete, stochastic, and dynamic so that we have the discrete event simulation. All right, so later we will have a discrete event simulation, but we don't focus on continuous system because we want to start from a simple one. Well, so let us have the description for the discrete event simulation. If we want to have the simulation, of course, we care about time. So later we have a time advanced mechanism. That says we need to have a clock. We call simulation clock. And based on the simulation clock, how to advance time. Here we have next event time advance. So we have a shorthand neta, or fixed increment time advance. It is called theta. And actually, we will heavily rely on neta, but sometimes you need to use theta. And maybe you have question, should we have the other approaches? If indeed you want to have the next one, you can try to have the mixture of the two approaches. At this moment, I already have the next event and fixed increment time advance here. Neta actually we have events, and we think if we don't have the event fall in between two non-events, so impossible. So that says we will go to the next event. And here we have some arrivals. And here we have a service. And so that we have departures. So we have events from arrivals. We have an event of departures after service, and then we have a departure. So we have arrival and departure, and no other events. Arrivals, we care about the event will be served once the event, once the customer has been served, and then it will leave. So we have a departure. Well, one comes and then starts service, then departs. Another one comes, then departs. Sorry, here, departs. All right. So we have the two events. And maybe you have a question, is it possible to have an event in between some other event? According to the current description, no. We don't have the other possible event because we can't numerate. Numerate then first one, second one, third one, first one, second one, third one. So impossible. But sometimes you have some assumption. It's hard to have the event time predicted or listed. So it's hard to use data. But current description, we should have the possible events first. And then if we know all the possible time instant, then we can advance time from the current time 0 to first one to next one and the others. If so, this is a way data. If we know the time for the event, or otherwise you cannot use data. And actually, we want that you have a system can apply data. So later we will have a system which can apply data first. So data actually where to start 0, right? So we have a reference time instant 0. And actually we have times of events. You can determine, or maybe you can determine the upcoming event. And if you know the time of the upcoming event, then you can advance time to that event. All right. And of course, the time of the system, the simulation clock can advance to that time instant. And so forth, you can continue this way. And finally, if you think about the measure, you can maybe you can collect enough event and then you want to stop. So you can stop it. Or maybe you can set a time to stop. So later we will that you have the two versions. Version 1, you can try to collect enough number of events and then you want to measure. Or maybe you want to stop when the time instant is reached. So we have two different approaches to stop the system, to stop the simulation. But currently we talk about next event time advance. We have these. Actually, we can refer to the current figure. We have 0 for the initial time, and we need to know all the possible times of event, and then we can know how to advance time to the proper time instant. And next one, it is called theta. Partly can have some given time instant or events. For example, event 1, 2, 3, 4, and the others. But we don't know exactly. So we can have a time interval. It's the fixed time interval. And we check fixed time interval. Oh, here, for example, we check any events up to now. Oh, we can find, yes, one event. So for this event, you start the service for that event at that time. All right, or maybe not at that time, but at least you know, oh, we have an event there. Perhaps you need to have the service from this one. So maybe you can do something, readjust, and so that you can have the further processing. But we will check at the time instant here. And likewise, the time instant here, oh, okay, no further event, perhaps no further event. And the time instant, oh, you have 2 events, and so forth. You check at the fixed time instance to know the events here or not, and so that you can have the associated processing for the system. If so, this approach we call theta. Because we emphasize theta, so we just let it know a bit here, but sometimes you will have the simulation based on theta. Theta actually is simple. At least compared to theta is simple. So actually, you can base on the current concept to have a simulation once you know how to have the simulation based on theta. So we emphasize theta, even theta for the discrete event system, not the complicated system, but at least we have a suitable way using theta, then you will know how to run simulation using theta. So theta here. All right, we just find the event using the fixed time instance. Well, if we have the system, we know some of, even right now, maybe we don't know the model, but we want to have the simulation. And actually, we can have the possible way to have the simulation. And then right now, we want to know, we want to run simulation, any other maybe components. Any other component to prepare? First of all, system state. We know we will define system state, and actually we have a simulation clock. Simulation clock, normally we have a simulation clock, but we don't mention because we use it, all right? And after that, well, after that, actually we don't have the computer simulation. Yeah, yeah. So maybe have sit first. Maybe you can sit here. Later, I ask you to join group 1. First time to join? Yes, and first simulation. Yeah, here. Group 1. Computer simulation? Here. Have a seat. Sam, you want to join computer simulation? Yeah, Sam, group 1. So actually, we have a system state simulation clock. All right, and later because of measure, we will have statistic counters, and actually we need to have initialization. We will have timing routine, event routine, library report, and main program. All right. So later we will have the preparation for all of these. So that's why we will check any other component. Actually, we list all the possible components for simulation here. Well, for new members, I should let you know we start since A40. All right, I have a bit time change, so we start since A40. And then to 11:20. All right, and if we want to have a break, maybe near or maybe the same as our bell like this, and then we will have a stop. Actually, we have 3 classes. It's 15, and 3 15, then we have 150. Actually, if we have a break only, then we still have the same amount of time. All right, so I start since 8:40 and will end 11:20. All right. And maybe for new members, you can check our recorded video on YouTube, and then you will know the syllabus and some requirement. And I have a short summary. We have one final exam, just one exam, and computer simulation. Okay, first good over there. Yeah. So I have a time change here for every week, every Monday from 8:40 to 11:20. All right. So let me continue. Right now, it is not the close break, so of course I should continue because later when we will have a break, 10. All right, so for all members, maybe you can think about this, but for the new members, I allow them to have the line QR code to scan. 所以你们已经加入的，你们先看一下，想想内容，我让他们加一下。So about new members, you should join this if everything is okay. Then you have this. First of all, this is a YouTube channel. If you want to find it at HWFERNG, right now we have a streaming already. But I ask you to join line group. Actually, for the old members, they have maybe some information or files. All right, so you need to join. And if maybe you miss some file, you just mention, oh, okay, any possible PPT slides. If you enroll in the course, actually you can browse the website of Moodle. Moodle right now already have syllabus. PPT slides for chapter 0 that says talking about syllabus and preparation for the final report and oral presentation. And right now we have chapter 1. All right, so of course you need to join. If you indeed want to say something through the individual messages, you can ask me to have a link with you privately through line for sure. All right, so if you want to take the course, of course you need to join the line group of the course. Actually, we have a Paul everywhere system, and later we have. So we'll check it. And of course, we have a Sky first. For Sky, maybe you can try to scan even right now. I don't start the Sky video conferencing, but if we have further discussion, then we will ask you to join the the Sky group if you are a presenter. And finally, this is Paul everywhere. and poll everywhere, and then we will have the answer from you. I saw that we have the records for you for the activities. All right, almost all. As for the others, you can check syllabus. So right now, so all of you join line group already. So let me check something for you. So after now, I pause again about chapter 0. We have 2 parts, so you can check it, line group. And now I pause chapter 1 for you. Same, you can check line group to have PPT slides for chapter 0 and PPT slides for chapter 1. All right, so you can browse the 3 files quickly, and so that you can catch up possibly. All right, so I already have some of that, and then let me get back to the PPT slides. And maybe for some of you, if you want to join the system here, the system actually you need to have a Microsoft account. If you have a Microsoft account, you can scan and join Present Live. All right, seems to be no, so let me continue. So we will have these components. Once we have these components, then we can have the routine for simulation, like this. So check this again. Perhaps we will have the suitable stat, and we'll have a simulation class. And then we want to let it know main program to have the routines. All right. Checking the current routine here, we have initialization. And we have a main program. Normally, so first time to join. So let me check members of the group 4, how many? Currently, 5, 4 or 5, 5. And group 5, 3, and then you can join group 5. And maybe I ask the member to show him the line ID. And group 1, maybe it's a new group. You join group 4. Here, you just come to, sorry. Okay, fine. Group 5, okay. Go there. First time, so let me check. So group 4, right now, how many members there? Yeah, count. How many members? Right now, 4. Okay, so first time to join, and let me, first time. Your first time to join? Okay, so same. Go to 4. Okay, You join group 2, that's okay. And here, oh sorry, let me make sure. Group 3, currently only 2? 2, or maybe you come here. First time to join? So join 2, no problem, here, come here. And you come here. Good one. Here. So maybe for the row here, maybe move 1 row 2. So we have a group 2. Group 2, same. First time to join? Okay, first time. First time.
I already had.
Sure, but first time to come to the camp. Okay. Join group 3. Okay, group 3. Here. So maybe you are the leader, right? Yeah, so maybe reorganize your group. So for all of you, you need to reorganize your groups, and once finished, then update the member list while that group align group again. And group 1, so Regis and want to tap the course. Make sure you want to join. Okay. And so I ask you to serve as the group leader and try to have the individual line group, and also find the name and ID so that you can then have the team members. All right. So you are the leader. Group 2 unchanged. Group 3 you. And group 4 same unchanged. Group 5 same unchanged. But you need to update group 5. And group 3 you need to update. All right, almost so first time to join. Okay, so you join group. Let me make sure. 4 for 2, and 4 for 1, and 5 for 3. And maybe you come here, join 4. 4, so how many members? Let me make sure again. 4. Okay. Okay, so you join 5, 5, 4, 5. Okay, 5 right now. Again, let me make sure. If you don't have you don't have changes, and then you need to let me have the update by line group. So this one, if you have the member change, then update that one. All right, let me get back to this. So we will start since F40. For the new member, we will start since F40. And then to 11:20. We just have a 1 break. All right, we just have a 1 break lasting for 10 minutes only. I think this one it will be easier. All right, even we have 3 classes. Okay, so let me go back to the components. We have initialization, main program, time routine, and the library event routine. Finally, it's the final generator. So let me count. Main program, and then we have 1, 2, 3, 4, 5. 5 routines. Data check. Is it correct? 5 routines. Main program, then 1, 2, 3, 4, 5. That's correct. So for the others, we will use them for some further discussion. So initialization, we should set time clock to 0. So simulation clock, we use it. So we have a clock. And we should initialize system stats, right? All right, and we have counters. So we have a stat, correct? We have this, we have counters. Oh, well, should we have an event? Actually, the event is absorbed in stat and or maybe clock or the statistic counter. So we still have an event, but we don't have the event to serve as a component. All right, so we should have we should initialize event list. For the map, oh sorry, maybe let me check the others first. Timing routine. Timing routine, the purpose for this routine, we need to determine next event. And next event, so we need to determine next event type. Therefore, we know next event type because we apply next event time advance approach. So we need to advance the time to that time instant. And to that time instant, of course, we need to have the suitable processing associated with this simulation. If we have a timing, then we can find the next event. And next event, you need to have the processing here. We have the processing event routine. You need to have the processing. The processing here because we want to care about the measure. So we will update stats and update statistic counters, and so that we have the corresponding processing. After finish the corresponding processing, we still need to generate future events. Future event, generate all the future event. No, just generate next or the upcoming event. For example, arrival, finish, then you need to generate the upcoming arrival. If it is a departure, then you need to associate the possible departure for the customers. So we will have the future event, or maybe you think it's the near future events, and add them to the event list. And library, I think normally we should have a library, so this one I think it's okay. But the library here, we already have the main component. It's the random variable or the random number. If we have the random number, for what? Because we want to have the random phenomenon for our simulation. Well, simulation over. Simulation over, we have two approaches. One, we collect enough maybe events and then we stop. Or maybe time's up, so we can stop. So simulation over, we have two possible approaches to stop the simulation. Once the simulation can be stopped, so we can have the repo. All right, how to have the repo? We will have the measures. Well, that's it. So this is the preparation for simulation. So let me have the maybe some simple ideas. To have a simulation, we need to have a system. Because of a simulation, we need to define model. Once we have the model, right now maybe we don't have all the details about the model. Once we have the model, then we can have a simulation. To have a simulation, we choose the simple one first, discrete event simulation. To have a discrete event simulation, we can have a next event time advance mechanism or fixed increment time advance mechanism. But we use NATA, that says next event time advance mechanism, to have the simulation. And to have a simulation for NATA, here, this one. So that's why we have an event. We talk about generate event and move the simulation clock or advanced simulation clock according to the time instant of events. Well, so summarize, I tried to review quickly for our current discussion. Flow chart for NATA approach. So this is the flow chart for NATA. To have a simulation, we can pass on this one. Well, I think it's enough. Even I prepare one empty slide here. I think that's enough. I already have all of these. Maybe John led, but I already have some possible idea about the current discussion in chapter 1. Well, this one, indeed, you need to join and you need to respond because we start the records for you since this week. After now, I already have the content of chapter 1. If maybe you have some question, you can leave your questions here so that I can answer to you. So this is a system, Paul everywhere. Paul everywhere is your first time. I expect you to register, and so that you can have student ID and your name. All right, and actually you need to show your name using screen name, including student ID and your name, and so that it will be easier for us to collect the records for you, because the records for you for this part participation. And I will collect the data since this week. And that's week, I think you ever have it. But right now, maybe why you cannot join. So anyone finish? Oh yes, no. Yeah, that's correct. So you need to respond. Currently, for some of you, you think no questions. That's good. Maybe not yet think, I have some question, but not yet to let me know. That's okay as well. So if this is the first time for you to use Paul everywhere, I expect you to have the registration on Paul everywhere, and so that you can have the ID. ID maybe using your student ID and name. Or maybe you are asked to have an email. By this, you need to show name using your student ID and the name. Well, then you not sure. If not finished for you, raise your hands. Okay, so keep going. And normally I should set a timer, but I forget this. So 1 more minute. And I always use the same QR code. You can find the QR code from our syllabus. Previously, I showed the syllabus, right? The QR code actually is fixed. I allow you to have these only. So if you fail to scan, you can key paulev.com/Huei-Wen 415, and then you can join as well. And actually, you can download, you can have the app Paul everywhere, and then you can key in your ID. Once I activate this, then you can join as well. This is a necessary system. Of course, you need to register. We have 4 systems. Line finished already, right? And this is the next one, Paul everywhere. And actually, we have a YouTube if you want to review. Or maybe sometimes if you think you want to join remotely, and then you can join Teams, YouTube. All right, let me check again. Not finished? Same? For example, right now you can skip and then key in, but you need to show your name. You can skip and then you can key in, but you need to show your student ID and name. Scan it again, but choose skip, right? At least you need to show your name, or otherwise it's empty. And next time you can try to register on poll everywhere. So okay for you? Once more, 1 minute for you. So up now, okay? Once timeout, I cannot wait for you. Then you will fail to have the record for this. Same, in the future, I will have the timer. If you cannot catch up, sorry, you will miss the points. 2 points associated with the event. So let me go to the next one. Well, we have an event, so it seems to me we should have an event scheduling. And personally, it looks like we have an event scheduling. But normally, if I want to have the generalized approach, it should be the process approaches. So after all, we have an event scheduling approach, right? And for process, something like we have a token, and the token flow through the possible entity. And that way, we have a flows, a token flows, and then we have the generalized approach we call process approach. Actually, for the current discussion, we don't know, but we don't have the current, we don't have the further process approach description. All right, so up to now, we don't have the framework of discrete event simulation, right? We end up with a poll to ask you any question. Up to now, maybe you say no, so we can continue, am I right? All right, if it is correct, then let me go to the, actually it's the core of this chapter. We have the program, then we have a simulation. Well, to have a single server, we ask you to have a barbershop customer, customer arrive at the barbershop and asking for service, and they need to wait. All right, maybe just one guy to serve all the possible customer, and then they will wait, and once finished, they will leave. So we have maybe an example like this. So if we want to have a stat for this system, we want to know status of the server, right? Server here, actually, that guy serve for you. So it's server. And also, how many customers waiting in queue? And of course, we need to know. You come here and we want to know the performance. Later, we want to calculate the delay. So of course, we want to know time arrival for each customer in queue. Of course, we will have a time of most recent event because we want to know next one. Here, This is a problem statement. We want that we have the inter-arrival time. Because we consider, in fact, it's the MN1 system. So we will have the IID, all right? IID, perhaps I have the maybe exchange position, but below side should be identically independent distributed random variable. Or maybe you can look up IID through Google, then you have IID. In fact, you can key in IID random variable, then you can have the definition for IID. So IID inter-arrival time and same IID service time. So here we have two assumptions for the later system. And how to serve first in and first out. So this is the queuing discipline. And here we have a system arrival, then in queue, and here is server. Once finished, then depart. In fact, I like this way. We have a queue. All right, we have a server and arrivals, and then departures. All right, previously it's the vertical version, but I have the horizontal version, and I prefer this one. Arrivals into the queue, and so that we have the server and then departures. At this moment, let me ask you this. If we have someone in the server, just one server, can the other customer be served immediately? No. Because of no, so they need to waiting in queue. So when the first customer, if we have a FIFO, first in, first out. So first in, first out, then we will have the first one. First one, we can have a specific name called HOL, head of line. All right, so head of line, when HOL can join, once server is idle or server is idle, previously the server is busy for serving the previous customer. But once the server is idle can accept HOL, and then HOL can be served and move it to the server. So that next one serving as a HOL. So we can continue this. So we study a system like this, and this system we call a single server. Queuing system. All right, single server queuing system perhaps is an example from the barber shop, or maybe the other possible situation. For example, waiting for your lunch boxes, right? So we focus on a system like this. Well, if we have a system like that, right now we try to have the Q of T. It's the number of customers in Q. All right, number of customers in Q. If we have events here, event 1, arrival. Is okay? Arrival, but why queue size is 0? Why? First one arrives, but why number of customers in queue is 0? Because this customer enter the server immediately. So we still have a 0 queue size. Is okay? And we assume departure for this one here, 2.4. So the next arrival, then you can see one waiting in queue. Likewise, this one waiting in queue. However, this one, service time of the first arrival, so remove the first customer, and so that reduce. So up to now, check the event. For the current rectangle, and specifically this one, enter the server immediately. So queue size is still 0. Before the departure, then accumulate, right? And this one leaves, of course, dropped. About the current phenomenon regarding the queue size, I call queue size here. You can check them for 1 minute. So about this one, any questions? How to have the current queue size if we have arrival departures arrangement like this? Of course, if we want to check the others, you can continue, but I just focus on the current rectangle. If you don't know, some numbers here, raise your hands. Okay, no, so this is a queue size. To measure the queue size, actually, we will based on the area here, but we already know how to have the possible rectangle to have the areas. And that one, actually, we have the area, but we just have a different statistics called busy or not. Here, you can call it busy. And it is called busy period. All right, busy period. So first arrival, yes. First arrival keeps server busy. All right, you can check to the others. So I think we don't want to have the size, but we just want to know the status of the server, B of T, busy or idle. If it's 0, it's idle. So look at this. We have 1, 2, 3 arrivals, and we have 1, 2, 3 departure. So arrival, departure, finally, it's idle. All right, so I think this concept okay, right? It's a busy period. Same, we care about the area, and so that we can have the length of the busy period to have the estimation of B of T. So previously we already have queuing delay, and we already have this system utilization. Based on B of T, we can have system utilization. Even right now, we don't really know how. And based on Q of t, we can have the queuing delay. And waiting time, how waiting time or sojourn time different from queuing delay? Waiting time including the time in the server. So this one including service time. So including the service time. So of course this one different from that. And queue size and system size actually it's number. And it's number. And same this one include the one in the server. All right. So of course, right now maybe you don't have any idea how to have the measure, but later we'll work based on this to have the measure. And the B of t, Q of t here actually work based on those figures, based on the concept of area to have for that. And Q length. Taking Q length as example. We may have some way to have that measure. All right, we have some way to explain the possible phenomenon. So we have the intuitive explanation given IID inter-arrival. So inter-arrival, look at this. Inter-arrival only 0.4 to have a first event. And then when we will have the second arrival, it's 0.4 plus. So the first one. And the second one is 0.4 plus 1.2. It's 1.6. All right. Here we have arrivals, inter-arrival. And service actually for the individual customer. So arrival, departure, and we have Q of t, B of t, and we have, of course, we have the corresponding figure of the task book. You need to have the task book. So actually, the empty page allow me to have the calculation, but I didn't know that previously. So we have initialization at 0. First one and second arrival should be 1.6. And actually you have the other. So we have inter-arrival. So how to have the time instant to have the arrival? We need to pass on the accumulation of inter-arrival times. And if we have some, maybe a system, a visible way to show the system stats, we may have these. Initial time, 0, so we check 0. And we prepare server status, number in queue, and times of arrivals, and all of these. And last one, 0.4. Server status 1. 1 means busy. All right, and number in queue, it's Q of t. And here it's arrival, times of arrival, next one. All right, now no next one, because we have a single one, so no next one. And number delay. Why number delay? Number delay actually we care about delay. So we have a term, the size. Customer, we want to measure its delay or their delay. So number delay actually is the size, sample size. All right, so right now 1 because just 1 enter, so 1. And actually number delayed, we know the delay already, then we count that customer. So right now the first arrival, but why the delay, the queuing delay has been known? Because queuing delay, first customer enter, and then what is the queuing delay? It's 0. No need to wait in queue. So 0 known. So of course we increase this one. It's 1. Sample size collect. It's 1. We care about queuing delay. So the queuing delay for the customer we know it's 0. So of course this one is 1. And total delay right now is 0. So no change. And area right now no and no. And we have arrival 1.6 for the next one. This one actually is the upcoming arrival and upcoming departure. For the first one, it's 2.4. Why it's 2.4? (2.0) plus 0.4, so it's 2.4. So actually you can always check this, but I check first event, all right? And actually we can have further initialization, but initialization check this. 0.4 for the upcoming arrival, right? Because 0, so next one given is 0.4, so it's 0.4. But why the departure we have infinity? Infinity says no, no departure. No upcoming departure. Why no upcoming departure? Zero, we don't know the event, right? No first event. So up to now, it's impossible to have any departure. So we set it to infinity. All right. But later, once we have a 0.4, and we can have the next arrival, and also for this customer, we can have a next departure so that we can replace infinity by 2.4. All right, so maybe some details, but the others I think it's okay. However, I have some highlight for the current figure. That I have 1 minute to think about this. So about the current figure, any questions? Okay, no, maybe we almost need our course break, but let me have one form for you to sign. Actually, this is a form called consent to record. In Chinese, 录影同意书，因为我们其实会有录影的进行特别是你们有活动的时候，就会转到你们那边。Okay, so actually all of you need to check and then sign it and return. Check it first.